Okay, myself Sweta Shah. I completed my diploma from Government Polytechnic and completed my BE from Government Engineering College Gandhinagar and completed my master's degree from SP University. I am working as a head of department electrical engineering in Ahmedabad Institute of Technology. Now, Ahmedabad Institute of Technology is established in 2004 and affiliated with GTU and approved by AICTE. Ahmedabad Institute of Technology offers following courses: bachelor course in electrical engineering, then mechanical engineering, computer engineering, IT engineering, electronics and communication engineering, civil engineering, and masters in business administration. Today we will discuss about elements of electrical engineering. This is subject of first year, and today we will discuss about fundamentals of alternating quantity. So let's start with today's topic. Before we start the fundamentals of alternating current, first of all I will introduce between direct current and alternating current. First of all, direct current. Now, direct current always flows in one direction, means the direction of current is constant throughout the time period. According to Ohm's law, as we know, for Ohm's law, voltage applied to a particular circuit is equal to product of current flowing through the circuit and resistance of the circuit, or you can rewrite the equation like this: I is equal to V by R. Same way, I is the current passing through the circuit, V is the applied voltage, and R is the total resistance of the circuit. Okay. Now, if applied voltage and circuit resistance are kept constant, then the magnitude of the current flowing through the circuit is also remains constant. Now, as we are discussed earlier, V is equal to IR, means if you are kept V as a constant value and same way resistance of the circuit is constant, means V by R ratio is remains constant, then it will give you the constant value of current. Now, if you are changing any of these two elements, then obviously the magnitude of current will be changed. Okay, if the value of applied voltage or circuit resistance will change, according to that value of current will also change, although the direction of current is remains constant. So this type of current is known as the direct current, in which the direction of current will never change. Magnitude of current may change if the circuit element will change. Now, as we are discussed earlier, that if any of the circuit element voltage or resistance will change, due to that the magnitude of current will change. This type of current is known as the pulsating DC. Means in this particular type of direct current, the magnitude of current is changes, but the direction of current is remains constant. Now, we are discussed the alternating current, which is known as AC. Now, the definition of alternating current is one which varies periodically in magnitude and direction over a definite cycle. Means in DC, the direction of current is always constant and magnitude of current is also constant if other elements of the circuit is remains constant. But when you are considering the alternating current, then alternating current, the magnitude as well as direction of current is changes with respect to time. Now, in alternating current, each cycle of alternating current containing two half cycle. In first half it contains only positive values, and in second half it will contains negative values. During one half cycle, as I discussed earlier, current varies in one direction, which is the positive direction, and during the second half cycle it will follow the opposite direction, which is the negative direction. Thus, to produce alternating current through an electric circuit, a source capable of reversing the EMF periodically is required, because it is a characteristic of alternating quantity that the direction of current, or you are consider a voltage, is changed with respect to time. So you are required a source which will reversing the direction periodically. Okay, this is the diagram which shows the pulsating DC and alternating current, and also the variable quantity. The first blue wave will indicate the pulsating DC. As we are discussed earlier, that pulsating DC means if you are changing the circuit element, means if you are changing the voltage or you are changing the resistance, due to that the magnitude of current will change. As shown in diagram, as shown in first wave, your magnitude of DC will change with respect to time, but the direction of flow is constant. So this type of current is known as the pulsating DC. Now second, this red line indicate the direct current or DC. This direct current indicate that the circuit elements, means voltage and resistance of the circuit, is remains constant. So you get the constant value of current, and the direction is always constant in DC. So first one is the pulsating DC, in which we are considering that circuit element will change, and second one is the DC, in which we are considering that circuit elements are remains constant. Now this green waveform indicate the alternating quantity. As we are discussing the definition, that's in alternating quantity containing two half cycle. This is the first half and this is the second half cycle. In first half, the quantity contains positive values. Okay, it start from the zero value, then increasing in a positive direction, get a maximum value, again start decreasing, but direction of the current is positive, again goes to zero, then increasing in a reverse direction, or you are consider it as a negative direction, and then again goes to the maximum value and again back to zero. So this waveform indicate the alternating quantity in which the direction as well as magnitude of the alternating current will change with respect to time. And this waveform indicate the variable quantity, means the direction as well as magnitude of the quantity will change, but it will not follow any cycle or any particular path. This path for this quantity is random, it will change according to the change of circuit parameter. So this type of quantity is neither AC nor DC, it is a variable quantity. So again, first one is the pulsating DC, second one is the pure DC, third one is the alternating quantity, and last one is the variable quantity. Okay, now after discussing basics of alternating current and direct current, now we are compare this to alternating quantity and the direct quantity. So first of all, AC. So AC voltage and current reverse periodically, as we are shown in earlier diagram, that voltage or current of alternating quantity is changes with respect to time. But while you are considering about DC, then voltage and current for a DC quantity is always remains constant whatever the time. Okay, this is another diagram which shows DC quantity as well as AC quantity. This first diagram indicate the DC source, means the direction as well as magnitude of this particular quantity is remains constant throughout the period. This is our time t. We are draw one diagram which will indicate the variation of voltage with respect to time. So this line indicate the magnitude of voltage and this will indicate the time. So throughout the time period, your magnitude as well as direction is remains constant. So this is your DC quantity. Same as we are discussed earlier, this is your AC quantity, which start from the zero value, goes to the maximum, again back to zero, goes in a reverse direction, again back to zero. So the magnitude and the direction of the alternating quantity is reversed periodically with respect to time. Now next point for a comparison, AC voltage can be step up or step down by using transformers. Now as you know, transformer is a device which will change the voltage level without changing the frequency. Means frequency of supply is constant, but using transformer you can change the voltage level. As we know, our generated voltage is 11 kV, which is generated by a power plant. So the generator output is 11 kV, but we are using AC supply for a domestic purpose. And for a domestic purpose, the value of the AC supply is 220 volt or 230 volt. So from 11 kV to 220 or 230, we can down by step down transformer. Same way, you can change the voltage level higher than 11 kV using step up transformer. But the condition is that the transformers are working only in alternating quantity. If you are given DC supply to a transformer, then it will not work. So no such provisions is available for a DC supply. This is one of the disadvantage, or you can say the demerits of the DC, that you cannot use transformer for a DC supply. So you cannot change the voltage level in DC supply. Now next point for a comparison is H.V.A.C, means high voltage alternating current transmission is economical by step up transformer. Now as we are discussed earlier that the AC quantity or AC voltage can be step up by using transformers, but in DC it is not possible. Now whenever you are consider about the transmission, the main losses occur in a transmission. It is known as the transmission losses, which is I2R losses. Means this losses is affected by the current passing through the transmission line and the resistance of the transmission line. Now as we know, once you are design a transmission line, the resistance of transmission line is almost remains constant. You cannot change the value of resistance. So only one parameter is there, which is the current that you have to limit. So when you are using high voltage AC transmission, means you are increasing the voltage up to high level, up to 220 kV or 440 kV according to the requirement. So when you are increasing the voltage, same way your current will be decreases. So your I2R losses will be decreases, which is known as the transmission losses. So for a high voltage you are decreasing the current, so I2R losses will decreases. So your transmission line losses will be decreases. So your transmission efficiency for a transmission line will increase. But this provision is not available in DC because no transformers are available for DC. You cannot change the voltage level for DC. So the current of the DC cannot be changed. Now next point for a comparison is AC can be converted into DC by using rectifier. As we know, rectifier is nothing but the combination of semiconductor diodes. Diodes means it is a semiconductor device, and the characteristic of diode is it will conduct into forward bias condition and it will not conduct during reverse bias condition. Now as we know, AC quantity will change with respect to time. Means the magnitude as well as direction of AC quantity will change with respect to time. When this AC is passes through the diode, which will flow the current only in one direction, so your AC quantity is converted into unidirection quantity, which is known as a DC. So AC can be converted into DC by using rectifier. It is nothing but the combination of diode. Same way, if you have to convert DC into AC for a particular application, then you can use a inverter. Inverter is also a combination of semiconductor device, and using this you can convert your DC voltage into AC voltage. Now next point for a comparison is cost of production of AC is less, while in DC cost of production is high. The reason is that as if you are considering the alternating quantity, then it is start from the zero value and gradually increases and reach up to maximum value. But while you are considering about DC quantity, then DC quantity has a fixed value. Suppose you are draw a waveform of 50 volt DC, then the magnitude of DC is 50 volt, which is constant throughout the period. So whenever you produce a DC, then some additional energy is required to reach up to 50 volt, while in AC it starts from the zero value without any external energy. Gradually it will increases and reach up to maximum value. So the cost of production, you can say the equipments required to produce a AC is less as compared to DC. So cost of production of AC is less as compared to DC. Now next point for a comparison is there is no dissipation of energy in AC generator, same as I discussed earlier that for AC it is start from the zero value, so no additional energy or extra energy is required to generate a AC voltage. But while in DC, suppose you are considering 500 volt DC, then the initial value of DC is 500 volt. As we know, if you are start your bike, then initial speed for a bike is 0 and gradually it will increases and reach up to 60 or 70 according to your requirement. But if you want that at an instant when you start your bike and your speed should be 60, which is not possible, and if you want then you have to add some additional energy so that your speed reaches up to 60 or 70. Same funda you can apply for DC, that if you are get instant value as 500 volt, so you require some additional energy. This energy is dissipated in the generator and you got a DC voltage. So this type of dissipation is not occur in AC, but it will occur in DC only. Now next point for a comparison is AC appliances and motors are more durable and DC appliances and motors are less durable. Reason is that suppose this is your AC quantity. This is your DC quantity. Now when you give a AC supply to a particular appliances, then what happen? Initially the value of AC is 0, then gradually it will increases, reaches up to maximum, again decreases, reaches to a negative maximum and then back to 0. Now when you are giving a AC supply to a particular appliances and if any fault is occur, then what happen? If fault is occur at this particular point, okay, then the voltage of this particular wave is 0 at this particular point, then current